So part A of this question from yesterday was to find the area of that region. So how do we find the area of a region? We take the upper bound and we subtract the lower bound. So it should just be the integral from 0 to 9 of the upper function, which is 6, minus the lower function, which is 2 root x. And then when we integrate this, we get 6x. And then we end up with x to the 3 halves divided by the 3 halves, which is multiplying by 2/3. So minus 4/3 x to the 3 halves from 0 to 9. Everybody good with that? And we plug it in, 54 minus, what does that come out to be? 54 minus 36, I believe, which is 18. So 1 point for the answer, 1 point for the integral, and 1 point for the correct setup. Everybody good with part A?
Yep.
Cool. All right, and on to the volume stuff, which is a little more pertinent for the quiz today. Part B, we want to write, but we don't need to evaluate an expression to give the volume if we take this region and revolve it around y equals 7. So if we want to go around y equals 7, that's going to give us a gap in the middle. It's going to give us a washer cross section because our region is not fully pushed up against that line. And so it ought to be the outer radius, which will be from 7 to 2 root x. Right, this right here is 2 root x, and the whole distance here is 7. So the outer radius, capital R there, is 7 minus 2 root x. So we'll have pi times our integral from 0 to, what was it going to? 0 to 9, I think. Is that right? Your outer radius is 7 minus 2 root x. And our inner radius, we go back and look. Our inner radius is just the distance between y equals 7 and y equals 6. So we could write that as 7 minus 6 squared if we wanted, or just 1 squared, or just 1. And this is good enough. This was worth 2 points, and this, the limits and the constant on the front, was worth 1 point. Everybody good there or no?
I wrote mine in terms of y. Would that be okay?
So you did it using shells?
I did the same integral thing, except I wrote like all the equations and the limits of the integral in terms of y.
No. The limits of these limits, 0 to 9, you did 0 to 6, or you mean you had this in terms of y?
I did 0 to 6, and then I changed the equation to y squared over 4.
But you still had 7 minus and 7 minus 6?
Yes.
No, that would not work, because if you revolve this around, the cross sections have a thickness of dx if you're going to do washers, so it would have to be in terms of x. You could have done shells and done, taking this and revolving it around, and then it would be a thickness of dy. That would have been an option, but if you did it using washers, it had to be done in terms of x.
Okay, I see. Thank you.
And then, yeah, so somebody was just asking if I could show how to do this one with shells. So yes, if we were doing part B using shells, like I just said, we have to do it in terms of dy, right? We have to do everything in terms of y. Our radius, or sorry, our height is just the value of x that we're going over here, right? Our height is just whatever x value we're at. And so the x value that we're at can be found by doing x equals y squared over 4. And then our radius ought to be the distance from 7 to y. And this is just a y distance here. So our radius ought to be 7 minus y. So we would do 2 pi times the integral from 0 to 6 of radius 7 minus y times height y squared over 4. dy. So 2 pi, height, and radius. Good or no? Does that make sense if you want to do it with shells? Okay. And part C was asking us, what was it asking us? It was saying that the region was now the base of a solid. So okay, the region is the base of a solid. Cross sections perpendicular to the y-axis are rectangles. I'll do this in green. And the base in it is 1/3 of the height that comes out of it. So we have a base and we have 3 times the base for this length there. So our area of our cross section should be 3 times the base squared. And so we then just need to figure out what that length is. And if we look back, that length is, well, it's the same as our height was when we did with shells with the other one, right? It's just x, and x is y squared over 4. So this should be 3 times y squared over 4 squared. And we'll just integrate that from 0 to 6, which you can distribute that out if you want, or not distribute, but just multiply it out if you want. Or you can just leave it as it is inside the integral there. And this was 2 points, and the correct limits in the whole, everything put together with the dy and the integral is another point. Does that make sense for part C? And that one has to be done in terms of y just because the cross sections were perpendicular to the y-axis. Any other questions on anything before we start the quiz?
How long did it take period 2?
The whole period. They were not finished when it ended. When the period ended. Some of them were finished, but not everybody. Dylan, yes, we will have more quizzes after this one. I think I've mentioned that multiple times in class over the past few weeks that we'll have like at least 2 quizzes every week on practice free response questions after this quiz. And then let's see here. So a problem, there was one other one somebody's asking about here, which was, let me scroll back up here, e to the x from x equals 0 to x equals 1, and we're revolving it around x equals 2. And the question was, could that be done using shells? So there's e to the x equals 0 to x equals 1. And we're going around x equals 2. And could we do it using shells? So we'd sketch our rectangle parallel to the thing we're revolving around and revolve it around there. And so the height of each of these would just be the function. So height would be e to the x. We'd be doing it all in terms of x because the thickness of that rectangle would be dx. And our radius then would be, if we let's see, it would be from 0 to, let me think about that for a second. And we're at x equals 2. Oh yeah, our radius would just be, yeah, I don't know why I haven't think about that. Our radius would just be 2 minus whatever x value we've gone over. I don't know why I was thinking that would be different. So yes, you could do it using shells, and it would be 2 pi times the integral from 0 to 1 of e to the x times 2 minus x dx. You'd have an issue with evaluating this integral just because we haven't learned how to evaluate. You know, if you distribute that through, that's 2 e to the x minus x e to the x. And the x e to the x part you wouldn't be able to do without a calculator until you've taken a second semester of calculus. But you could set up, I mean, this would be the correct setup. That would work just fine. And if you were allowed to use a calculator, which you won't be on the quiz, you could just plug that in. But there's nothing with it. I mean, all the functions should be fairly straightforward functions on the quiz. So nothing with like an x e to the x that you wouldn't be able to do. Any other questions?
Are we allowed to use Desmos to graph?
I mean, if you want to look at it, that's fine, but I want to see all of your work and, you know, see a sketch of the graph in your region if, you know, if that is necessary for the problem, which most of them I think it is. So please show everything that you do.